Today's a little bit more about definitions than just about anything else. Let's say you have this, 3, 6, 9, 12. By the way, this is how 5th grade started for y'all, in case you forgot, those of you that were here. When you have a sequence, please understand this in case we forgot. You know, we call this the first term of the sequence. This is the second term, and so on, and so on, and so on, and so on. These are all terms, first, second, third, fourth, fifth, sixth. You will notice these are two different types of sequences because how do you go from one to the other? Well, what is this? To go from 3 to 6, what do I do? Now you could multiply by 2, right? But 6 times 2 doesn't give you 9, so you got to abandon ship and go, what am I supposed to do? Plus 3 or add 3, as we say in 7th grade. One of the two works, I guess. Okay. If your sequence, if the sequence is by addition or subtraction, we call it an arithmetic sequence. Which I'm going to look up the spelling because I always seem to get arithmetic wrong, which is ironic, isn't it? It's arithmetic if you get the next terms by adding or subtracting. This one, however, is not done by adding or subtracting, because if it was, you'd go 3 plus 6 is 9, 9 plus 6 is not 27. In this one, what do you do every time? You multiply by 3 every time, which we call not a common difference, but a, there's got to be another word for it. Oh, common factor. Sorry. Common factor. Those types of equations we call geometric sequences. I'd rather go with the arithmetic ones. Geometric is by factors. Now remember, your factor could be a fraction. For example, if you had this, gosh, I don't know, 64, 32, 16. What am I actually multiplying by? Anybody? I'm not multiplying by 2 because 64 times 2 is 128, not 32. I'm actually multiplying by, no, you're not multiplying by a negative because 64 times any negative would give me a negative. John! 0.5, which is a half. I'm actually dividing by 2, which is the same as multiplying by 1/2. So what would be my next 4 terms? If I divide 16 by 2, I get 8. Divide 8 by 2, I get 4. Divide 2 by 2, I get, or 4 by 2, I get 2. And then divide 2 by 2, I get, how about the next term though? What would be the next term? Again, remember you're multiplying by a half. What's 1 times a half? Is it rocket science? 1 times a half? Half. What's a half times a half? What's a 4th times a half? What's an 8th times a half? And it would keep going forever and ever. But if you use decimals, you'd start getting some crazy goofy decimal numbers, so you probably want to use fractions there. Here is the questions that they will ask you. Write the formula for this. Write the formula for this sequence. 3, 6, 9, 12. Do we already have that? 3, 6, 9, 12.
We We already had that.
I know, but we don't have the formula for it, though. If you're asked to write a formula, here is what it would look like. Let me give it to you. A to the subscript n equals 3 times n. And please say, huh? Okay. First thing one must realize is this. When you talk about these little numbers that are to the bottom of numbers, they are not exponents or powers. Okay? If the little number is up here, we call it an exponent or power. If it's down here, we call it a subscript. Sub, below. Actually, these numbers up here in real world are called superscripts, but subscripts do not have anything to do with the number other than to give it a name. It's only a way to label. It's not a mathematical thing to do, it's just a way to label. And when you talk about sequences, the letter n is the number of the term. Okay? Which means this, boys and girls, see if this makes any sense to you. If n is the number of the term, and I have an a in front of it, the letter A stands for the value. This says the value of any term. The value of any term that you might want is 3 times whatever term it is. So for example, look, first term, so n would be 1. This is the first term. N is the number of the term. What is 3 times 1? Somebody? 3. 6 was the second term. So 3 times 2 is 6. This is the third term. 3 times the third term is 9. Because if I wanted to know what the 35th term is, you don't want to have to write the whole sequence down. You'd rather be able to put it into the formula. And the way the formula would look would be this. We know that n, what term am I looking for? No, I said I want to know what number term. Is anybody listening?
36.
I want to know the 35th term. So I would write it out like this. The 35th term, this is not a number right now, is 3 times 35, because that's what the letter n is in my formula. So the 35th term is what? What is that? 105? What would be the 100th term? Writing it out, it would be a 100th term is 3 times n, and we know that n is 100, so it's 3 times 100, which is a to the subscript 100 is 300. And again, this is just a label to get you to that. Now, lest you be confused, let's change this. What if, going back to this one, remember when I had 3, 9, 27, 81, ... What would be the formula for that? It's different than that because this is for a arithmetic one, this is a geometric one. And it would start out the same. A to any term is... Anybody? This is the first term. This is the second term. This is the third term. This is the fourth term. Can anybody give me a formula that would find the fifth term? That if I didn't need to know those numbers before. Anybody? Oh boy. Nobody's going to take a guess? Please take a guess. Zach? No. Anybody else? Wait, what were you going to say, Zach? I'm sorry.
The number times 3.
I already did that. Look. Let's try that. Zach says the number of the term times 3. Works for this one, yes? 3 times 1 is 3, but 3 times 2 is not. Huh? Say it, because I think you're close.
To the second power.
Huh?
To the third power.
This is to the second power. This is to the third power. So what is my formula? It's not 3 times n, it is what, Madison?
AN equals n times 3.
That's the same thing as 3 times n.
I mean,
Zachary's got it, you just gotta say it to me. Yes, Zach,
AN equals 3 to the 3rd power.
but that's not a formula. AN equals 3 to the 3rd power would definitely give me this. But that's not gonna help me if I want the 5th power, or the 5th term. Joseph,
AN equals 3 to the n power.
look at Joseph. Everybody give him a big round of applause. 'Cause that's what it is. If it is a geometric formula, your letter n is going to be the exponent of whatever it is. 3 to the nth power. Look, because 3 to the 1st power is 3. 3 to the 2nd power is 9. 3 to the 3rd power is 27. 3 to the 4th power is 81. And 3 to the 5th power would be a to the 5 equals 3 to the 5. And what would 81 times 3 be? I know you can't do that. 243. Okay. Unfortunately, with all the bewilderment there, we're going to have to stop right there because there's only so much math you can handle before you explode, and I believe we went past that many things.